These are the frequently asked questions for pre-calculus for section 6-1, day 1. I'm going to start with number 12 here. The first thing we want to do is get these vectors in component form. Like it says, find the component form and magnitude of the vector, because the component form allows us to do a lot of really basic math. So if we're looking at vector PS, that means we have to work with the points P and S. And all we have to do to get that component form is do some subtraction. That subtraction is from the terminal point back to the initial point. And the arrow here always shows us which one of these two is the terminal point. So we need 2 minus a negative 2, which is going to be 4, and negative 8 minus 2, which will be negative 10. So this is the component form of the vector PS. Then we need to do PQ, because we're trying to build an equation here, and that equation is PS minus 3 times as a scalar times PQ. So we had P up there before. Q is going to be our new terminal point, and Q is not a negative something, it is 3, 4. So vector PQ. Three minus a negative 2, which is 5, 4 minus 2, which is 2. And like I said, now we can use this as an equation for what we need here. So we've got our component forms, 4, negative 10, and then we'll go ahead and add what we get from the scalar multiplication of negative 3. So that will be negative 15 and negative 6. And then we'll go ahead and add those component pieces together, horizontal to horizontal and vertical to vertical. So 4 plus a negative 15 is negative 11, and negative 10 plus negative 6 is negative 16. So that's the component form that they wanted. So we go back up and we see we're not done yet, because it said find the component form and the magnitude of the vector. And the magnitude of the vector in component form, we use the distance formula, but we get to use it with 0, 0. And so that means instead of the square root of x sub 2 minus x sub 1, the quantity squared, plus the square root of y sub 2 minus y sub 1, the quantity squared, we basically just use, in terms of a and b, a squared and b squared. So it's the square root of negative 11 squared plus negative 16 squared, because negative 11 minus 0 is negative 11, and negative 16 minus 0 is negative 16. So that's going to be the square root of 121 plus 256, pardon me, and that is the square root of 377. Better make that readable there. And we're going to leave that as is. So here's our component form, and here is our magnitude. Next one up, I had talked in class about how 39 and 40, we really hadn't had a chance to talk about that whole unit vector and its uses. So in this case, it says in exercises 39 and 40, find a vector v with the given magnitude and in the same direction as u. And what we need to do with that unit vector is it gives us a vector that is in the same direction as the vector that you originally had. So when we find that unit vector, it will point us in the same direction as u. So that's the first thing we need to do, and that will be 1 over the magnitude of u times our vector u. In fact, I'll just use u right here. Again, you could write it as u over the magnitude of u, but either way, you're going to end up getting what you need. So that magnitude is going to be using the 3, negative 3 with the distance formula and 0, 0, which basically makes this the square root of a squared plus b squared, and this is a and this is b. So that will give us the square root of 3 squared plus negative 3 squared, which is of course 9 and 9, which is the square root of 18. So now, once we have that square root of 18, it's really hard for me not to want to rationalize that. So I'm going to go ahead and change that square root of 9, square root of 2 into 3 square roots of 2. So there's our magnitude. So we'll have 1 over 3 square roots of 2. Let me take that equals off there because I'm going to do this in pieces. So this is my 1 over the magnitude of u, and I need to take that times the original vector. And that will give me my unit vector. So, good news and bad news. Well, if we multiply this through, can think of these two as fractions, top times top, bottom times bottom, the 3's are going to cancel out because we'll have 1 over 3 square roots of 2 times 3 over 1. But then we should rationalize the denominator. So 1 over the square root of 2, multiply the top and the bottom by the square root of 2, and we get the square root of 2 over 2. Which we should be used to anyway. You know, think about your cosine and sine of pi over 4. Now, we've got a negative 3 doing the same thing. You know, 1 over 3 square roots of 2 times negative 3 is just going to give us a negative square root of 2 over 2. So this is our unit vector. And that ensures the same direction that we have for vector u. But the magnitude of this vector needs to be 2, not 1. So what we have to do is take our unit vector and we have to use a scalar to multiply it by to get it to have a magnet of 2, which it just makes common sense that we would need to multiply it by a 2 in order to get that. So if we multiply this by 2, we are going to get the square root of 2 because the 2's would drop out top and bottom, and the 2's would drop out top and bottom of this one. And that meets the requirements of this problem. We do have that magnitude of 2, and we do have the direction because the unit vector provided that direction. Number 40, same type of problem. So we're going to start the same way. We're going to figure out what we have for that unit vector. So let's figure this out. Square root of negative 5 squared plus 7 squared. So we have 25 plus 49. That will be the square root of 74. Not beautiful, but you know what? We've worked with worse. So 1 over the square root of 74 times the original components, negative 5 and 7. And that will give us negative 5 over the square root of 74. And notice I'm not rationalizing the denominator on this one because that's not going to be anything nice. We are very used to working with the square root of 2 over 2, but not 5 over the square root of 74. So we're just going to leave that. And then our scalar of 1 over the square root of 74 times 7. So negative 5 over the square root of 74 and 7 over the square root of 74. Now, we're not done. That's our unit vector. So now that has the direction that we want it to have, but we have a new magnitude. We want a magnitude of 5 on this, so that means we're going to multiply this by that scalar of 5. And a 5 is just like a 5 over 1, and with fractions you multiply top times top and bottom times bottom. And you probably will not find that answer in the back of your book. You know, this is not nice, and so they're generally not going to leave that. They're going to go ahead and decimalize this and put it into a calculator. So negative 25 divided by the square root of 74, we will get negative 2.906, and then 35 divided by the square root of 74, 4.069. And that would be what we were looking for right there. It will have a magnitude of 5, and it will be in the direction of the vector that they gave us. And that is it.